Chapter 9 is over systems of equations. So instead of just one equation, we have two or more considered together. We'll be looking at what do solutions look like. And for now, we'll be talking about linear equations. What does the linear equation mean? Straight lines, yeah. If it has two variables, it'd be a straight line. But what I want you to think of is exponent of the variables is 1. And the reason why I want you to think of it this way is because in the future, we'll use 3 variables. If you have 3 variables, the graph would be not a line, but a plane, a flat plane. In 4 variables, it would be a 3-dimensional space that's not curved. So I just really want you to think of the exponent of the variable being 1. So 2x minus 4y is equal to 3 is a linear equation because my exponents are. And if I have more variables, 9x minus 4y plus 3z is equal to 10. The exponent of all the 3 variables is 1. But for today, we'll be talking about only x and y, 2 variables. So if I graph 2 lines, one way that they could interact is they could intersect at a single point. So this could be one line, this could be another, and the solution would be the points they have in common. This is the ordered pair that when we plug it in to both equations, it makes them both true. So for instance, if I picked another ordered pair over here, if I plugged it into the blue equation, make it false. If I plugged it in the green equation and make it false. Or if I picked a point over here, it'd only make the blue equation true and the green equation false. What do I mean by that? Can anyone tell me the equation of this blue line? What's the y-intercept? 1. What's the slope? All right, very good. So if I plug in a point like, actually, let me pick a nice point here. This is the point 4, 3. So if I plug it in here, 3 is equal to 1/2 times 4 plus 1. Is it true? Yeah, 3 is equal to 3. This is true. Okay, but if I plug it into, what's the equation of this green line? Y is equal to, yeah, this should be a y-intercept of 5. Plus 5, and the slope is down 1, 2, 3, 2. Negative 3/5 x. So if I plugged in the point, what? 4, 3. So y is 3. Negative 3/5 times 4 plus 5. This is false. This is not true. Because this point was on the blue line and not on the green line. Does that make sense? But if I plugged 2, 2, would it make both equations true? Okay. I don't know. It should be 3/2, right? Thank you. Negative 3/2. Let's try this again. Okay, is this true now? It better not be. 3 is equal to negative 6 plus 5. No, that's false. 3 is not equal to negative 1. Okay, what if I plug in 2, 2? 2 is equal to negative 3/2 times 2 plus 5. Negative 3 plus 5 is 2, so it's true. And on this one, I would get 2 is equal to 1/2 times 2 plus 1. True. I found this ordered pair that makes them both true, and there's only one. How do you know that there's only one solution here and not more? It's a straight line, right? It can't curve back around and intersect again. So that's one scenario. The second scenario, what if our lines are parallel? Meaning they have the same slope, different y-intercept. We call this an inconsistent system. They cannot both be true ever. So we would say this system has no solution. And finally, what you might find is you graph one equation. You know what? Let me make an equation that we can actually find. Maybe I'd say this line is y is equal to a y-intercept of 2 and the slope of negative 1. And what if I gave another equation that's exactly on top of it, but maybe we didn't recognize it's the same equation? So I might say, I don't know, 3x plus 3y is equal to 6. Okay, it turns out these lines are exactly the same. So how many solutions does this system have? Infinite. Okay, but we can't say that every single order of pairs is a solution, even though it's infinite. Right, so for instance, is this order pair solution? No. Okay, but it has infinite solutions along this line, right? So how do I represent all of those infinite solutions on the line? What we're going to do is we're going to say, if you solve for y, we say this is our y value and x is our x value. So it's a dependent system, and the solution set is all ordered pairs of this form, where I plug x in, and for y, I plug in negative x plus 2, such that x is a real number. And this is how we're going to represent every value on the line. Any questions about that? And this is a dependent system. Let me just verify that the homework writes the answers like this. Yes, it does. It says is any real number. Okay, so this is how we're going to write the solution set for a dependent system. And we'll define what solution is. The solution set to a system of equations is all ordered pairs that make every equation in the system true. One thing we're going to do is solve by graphing. So let me ask you, is this a linear system of equations? So this one's linear because 1 and 1, right? But this is nonlinear because of the 2, right? So that's a parabola. So this is a nonlinear system, and we'll solve those in section 9.3. But we can solve by graphing. How many solutions does this system have? 2. And what are they? 3, 9, and -2, 4. So how could we check that? Plug it in. Is it true that 4 is equal to -2 squared? Yes. And it must simultaneously be true. Is 4 equal to -2 plus 6? Yes. Therefore, we have confirmed that -2, 4 is a solution. Okay, then likewise, we could check that 3, 9 is a solution. Is it true that 9 is equal to 3 squared? Is it true that 9 is equal to 3 plus 6? Yes. So 3, 9 is also a solution. So graphing is nice because you can visually see where they intersect. Any questions about this? All right, I'll ask you a conceptual test-like question. How many solutions can a system of a parabola and a circle have? Give me all the scenarios, but most would be one of the answers, sure. Okay, I heard 2. A circle and a parabola could have 2 solutions. Do you agree? What happened? Undo. Okay, there's many right answers. 2 is correct, right? It could have 2 solutions, right? What else could it have? 4? 4? Sure, a parabola and a circle could intersect 4 times. 3? Yeah, if you want to get really crazy, they could. Yeah, they could barely touch at the bottom, right? 7. Could it intersect once? Once, if it just kisses at one point? Sure, why not? Then that's no solution, right? No solution. All right, is that all of them? 1, 2, 3, 4. Yeah, that's good. Okay. We're going to solve by substitution. Are you familiar with substitution? So the advantage is this method always works, as opposed to graphing, right? Graphing has an issue. For instance, what if my points intersect here? What is this x value? That could be any nasty fraction. I have no idea. So graphing doesn't always work because it's hard to find the fractional solutions. So we'd like to do substitution. So what we do is we plug one equation to the other, and one of three scenarios happen. You can either solve for x or y, which will imply that you have one solution and you'll have to find it. It'll mean they're intersecting lines. We could plug one equation into the other and get something absurd like 5 equals 7, which is never true no matter what, which means the lines are parallel and we'll say there's no solution. Finally, you could plug one equation to the other and get something like 4 equals 4, an identity. And that tells you the lines were identical to begin with, and you need to write the solution set of all those solutions. So let's go ahead and practice this. Example 1. Which equation looks easiest to solve for a variable? Equation 1 or equation 2? Yeah, we like to isolate which variable? Y. Okay, so we'll subtract 3x from both sides. Y is equal to negative 3x plus 8. Now that we've gotten y by itself, we're going to plug this into the other equation. 5x plus 3y is equal to 8. But let's go ahead and plug in negative 3x plus 8. Any questions about that? You've all done this before? Yes, so it's nice. We've now combined the equations and we have only one variable to solve for. So now we can solve for x, hopefully. We distribute the 3, we get 5x minus 9x plus 24 is equal to 8. 5x minus 9x is negative 4x. Let's go ahead and subtract 24 from both sides. Negative 4x is equal to negative 16. We divide by negative 4. And we get x is equal to 4. So what does that mean? Are my lines parallel, the same, or intersecting? Yes, it means they intersect when at the value x equals 4. So if you're able to solve for x, it means, or y, lines intersect. So now we need to find the y value where they intersect. How can we find that? Plug in x equals 4 into which equation? Does it matter which equation I plug it into? No, because this point is on both lines where they intersect. This one looks easiest. Y equals negative 3x plus 8. Let's go ahead and plug in 4. And we get y is equal to negative 4. So my answer is 4, negative 4. Could I have a second solution? No, because they're linear equations. Straight lines intersect only once, not at all, or infinitely many times. If they're nonlinear, then I could possibly have more solutions. Any questions about this? So once I find x, I can plug it into either equation or any form of either equation to find y. If I wanted to check this is the answer, I'd have to plug it into which equation? To check, you must plug in into both equations. Any questions so far? Let's do example 2. Last time we solved for y, let's solve for x. So if we get x by itself, let's subtract y from both sides. X is equal to negative y plus 5, and let's plug this into the other equation. That gives us 3 times x plus 3 times y is equal to 6, and we'll plug in negative y plus 5. After we distribute, we get negative 3y plus 15 plus 3y is equal to 6. The 3y's cancel. 15 is equal to 6. What are your thoughts? Yeah, that's absurd. This will never be true. We say it's an inconsistent system, but more specifically, it should say solve, which means find all solutions. So the more important answer is no solution. No solution. I think on your homework, it writes two curly braces with nothing inside, which means empty set. No solution. If you're really lazy, you can write this symbol, also means empty set, no solution. I'm not going to say lazy. If you're efficient, right? Get the same message across with less writing. Next one. Let's go ahead and solve this one for x. That looks easiest. Let's add 3y to both sides. And we get x is equal to 3y plus 4. What's the next step? Okay, we plug this in for x in the other equation. 3y plus 4, distribute the 2, and we get 6y plus 8 minus 6y is equal to 8. Y's cancel. 8 is equal to 8, which means they're the same line. So the tricky part is, how do we write our solution set? We know there's infinite solutions, but how do we represent every ordered pair on the line? Okay, this one is solved for x instead of for y. So I could say, if I plug in y here, or y value, then x would be 3y plus 4. Such that y is any real number. This is one example. Or I could solve it for y. If I solved it for y, it would be negative 3y, subtract x from both sides, is equal to negative x plus 4, divide by negative 3. Y is equal to 1/3 x plus 4/3. So on your homework, I think it more commonly writes the answer when you solve for y, in which case we're saying we plug in x value, and the given y value would be 1/3 x plus 4/3, where x is any real number. Yes, positive divided by negative is negative. Thank you. Plus 5 points out of 6 for Professor Rao. All right, any questions about that? The plus 5 over 6? Oh, that's my score on this problem. I only earned 5 out of 6 points. You might sign error. Are you familiar with solving by elimination or addition? We want to eliminate, let me erase this so it doesn't confuse people. We would like to eliminate a variable, but instead of substituting, we want to create opposites and cancel. Okay, so this is the setup for elimination method. Okay, you agree that I can add the same number to both sides of an equation? I can do 9 plus 7 and 9 plus 7 on both sides. And I get an equation that's still true. 16 equals 16. Okay, what if I say that 9 is equal to x? Can I add 7 to both sides? And say, now 16 is equal to 7 plus x? It's still true, right? Still 9 is the solution here. Okay, and now what we're going to do instead is just say we can add sides of an equation together. So if I have two equations, I can add the 8x plus 2x to get 10x, the 8y plus negative 8y to get 0. And I can add the right-hand side together, 10 plus negative 5 to get 5. So just like I could add 7 to both sides of an equation, I can add sides of equations together. It's called the addition method because we're adding sides together, sometimes called elimination method because we're eliminating the y variable by having opposites, negative 8y, positive 8y. Add to make 0y. So the goal is to eliminate one variable. The problem here is, what happens if I add these together? What's 3x plus negative 5x? Negative 2x. What's negative 8y plus 4y? I didn't actually eliminate a variable. Does that make sense? Yeah. Sure. Multiply what by 2? Okay, so what I want to do is look at a variable and say, I'd like these to be opposites. So what's the smallest number that 8 and 4 go into evenly? An 8, right? So I'd say I'd like these to be opposites. So I'd really like to have a negative 8y, which I have, and a positive 8y. So then I say, I'm going to multiply this equation by a number to give me 8y. And that number is 2. So equation 1 is still 3x minus 8y is equal to negative 6. And the second equation changes when I multiply both sides by 2. And what does it become? Negative 10x plus 8y is equal to 20. So now we've created a scenario where I can add the sides of the equation together. If I add this side together, then I get negative 7x and the 8y's cancel. We eliminate the y variable by design. On the right-hand side, we add these together and say, what's negative 6 plus 20? 14. Okay, and now we can solve for x. Negative 7x equal 14. How do we solve? Divide by negative 7. See if I can make... I won't make the same mistake twice. Negative 7. I'll just divide by negative. I don't know. I did make a mistake, huh? It's negative 2? Okay. What does this mean? Yeah, it means they intersect just like before. So we need to find the y value. Let's plug into any form of either equation. Which equation looks easiest to plug into? Don't stress too much. You get the same answer either way. So I heard 3x. 3x minus 8y is equal to negative 6. Let's go ahead and plug the negative 2 in here. The answer, negative 6 minus 8y is equal to negative 6. We'll add 6 to both sides. Negative 8y is equal to 0. Divide by negative 8. And we get y is equal to what? So our solution is negative 2, 0. And you know what? I'm really unsure of myself. I'm making a lot of mistakes today. Let me check. How can I check? Plug into both, right? So 3x minus 8y is equal to negative 6. Let's plug in negative 2 for x, 0 for y. Is it true? This is 0. Negative 6 equals negative 6. So far, so good. But it must be true for both equations. What is negative 5 times x plus 4 times y? Is it equal to 10? Negative 2 and 0. So what's negative 5 times negative 2? Yes, 10 is equal to 10. Okay, now I feel very good about this answer. Made both equations true. Any questions about this? Let's try the next one. Okay, I'd like to work with the smaller numbers. So I'd rather work with the 2 and the 5 rather than the 6 and the 15. I could work with either. So I ask myself, what's the smallest number that 2 and 5 go into evenly? Okay, so I would really like to make a 10x and a negative 10x to cancel. For the first one, I'd like to multiply both sides of the equation by what? 5 or negative 5? Pick your poison. Okay, multiply both sides by 5, and we get what as our equation? 30y. Okay, and on the other equation, we'd like to multiply by what? Yes, I'd like to make it negative, so we multiply by negative 2. What's negative 2 times 5x? Negative 10x, negative 2 times 15 is equal to... So we add the sides of the equation, and what happens? 0 equals 0, right? So what does that mean? Dependent. So that means whatever you plug in for x, it will always be true. So we need to solve one of these equations for x or y. 2x plus 6y is equal to 4. What do you want to solve for? It doesn't matter. If I solve for x, though, I won't have any fractions, which is nice if you're a little OCD. So x is equal to what? Negative 3y plus 2. Okay, so our dependent system, we need to represent every ordered pair on the line. So I'd like to plug in a value for y, in which case my x value would be negative 3y plus 2, such that y is any real number. Any questions about this? All right, there's two types of word problems that are going to show up with systems of equations. These are word problems you've already done before on the first test. The only difference is we can use two variables, x and y, opposed to just one. I heard wait. Was there a question about example 5? How do I check my answer if it's dependent? Right, I can't plug in solutions now. So these should be exactly the same. You could solve them both for x and check that you get the same exact equation. Would be another way to double check. So if you really want to be extra careful here, 5x plus 15y is equal to 10. We could subtract 15y from both sides. 5 by 5, x equal to negative 3y plus 2. Yeah, they're the same line. Okay, the most common word problem they give in the section is wind and current, or wind and current. So wind, we're usually talking about a bird or a plane, something flying. And in the current, we're usually talking about a boat. Okay, in the case of a plane problem, we have the rate is going to be P is the rate of plane with no wind. So we should define that variable. Maybe I'll define that first. P is equal to the rate of an airplane with no wind whatsoever. Okay, so when you're going with, the wind is going to push you faster, and so we add the rate of the plane plus the rate of the wind. So we'll say W is equal to the rate of the wind. And in the case where we're flying against the wind, we subtract the rate of the plane with no wind whatsoever minus the rate of the wind. And we multiply by time to get distance. Actually, the most convenient form of this equation is actually when you divide by time. P plus W is equal to D over T, and P minus W is equal to D over T. Because these are already set up for elimination, we can just add them together and we're done. Let's try example 6. A plane flying into a headwind flew 270 miles in 3 hours. Flying with the wind, the plane went 260 miles in 2 hours. Find the rate of the plane and the rate of the wind. P, W. Okay, so rate is equal to, we said distance over time. And we have two equations, or we'll say two scenarios. When we're going with the wind and when we're going against the wind. Which equation is given by the first sentence? Are we talking about with the wind or against the wind? Into a headwind is against. Okay, so in this case, we would have P minus W or P plus W. Yeah, against the wind, we subtract is equal to how far did we travel? 270 miles in 3 hours. 270 over 3. So the next sentence says when we're going with the wind, so in that case, it would be P plus W is equal to, very good, 260 miles in 2 hours. Let's go ahead and simplify this a little bit. P plus W is equal to 130. Just gonna wait for you guys to answer so I don't get these wrong. P minus W is what? Equal to 90. And the nice thing about this is it's set up for elimination already. Right, we can add the sides together. And on the left-hand side, we would get, I have 2P is equal to 220. And so that means that we're going to have a single solution. Divide by 2. The rate of the plane is 110 miles per hour. Is that reasonable? Maybe a small airplane? Okay, yeah, and so we can plug this into either equation. You were saying that this one, P plus W, but we'll use 110 is equal to 130. Subtract 110 from both sides, and we get W is equal to 20 miles per hour. Are there any questions about this? We have a mixture problem. In algebra, to find n unknowns, you need n equations. So in this case, we have 2 unknowns. We need 2 equations. A goldsmith has 2 gold alloys. The first alloy is 40% gold. The second is 60% gold. How many grams of each should be mixed to produce 20 grams of an alloy that is 52% gold? What's the equation here for a mixture problem? Amount, in this case, we're talking about of an alloy times the percentage of gold is equal to the quantity of pure gold. So I'll set up a chart. You certainly don't have to. And we'll talk about the 2 things that we're mixing together. We have a 40% gold alloy. And we have a 60% gold alloy. And we're going to mix them together to make some mixture. So first thing we'll do is convert these percentages to decimals. 40% would be what? Yeah, 0.4. And 60% is 0.6. The mixture would be 52%. 0.52. The question's asking for how many grams of each, which means that they're unknown. I don't know how many grams of 40% alloy. I don't know how many grams of 60% alloy. And I use different variables because they're not necessarily the same amounts. Okay, so the only thing I'm not using here is this 20. How does this 20 come into the picture? They're mixed of what? Yeah, it's the amount of the 20%, the mixture, right? So in the mixture, we have a total of 20 grams of the 52% alloy that's been mixed together. Once you fill these all out, you can multiply across to get 0.4x, 0.6y. I'm going to leave this for now, 0.52 times 20. And we need 2 equations. Can anyone tell me what one of the equations are? So if I'm mixing these 2 together, x plus y is equal to 20. I'm also mixing the 2 together here to make the combined mixture. 0.4x plus 0.6y is equal to 0.52 times 20. Are there any questions on setting this up? Do you want to use substitution or elimination? Okay, so what should I multiply the green equation by? Do you want to eliminate the x variable or the y? Sure. So I should multiply by what? Negative 0.6. That gives me negative 0.6x minus 0.6y is equal to 6 times 2, negative 12. So we add the sides together and the y variables eliminate, and we get negative 0.2x is equal to, anyone have a calculator? Is it 10.4? Is this 10.4? 10.4 plus negative 12 is negative 1.6. We divide both sides by negative 0.2. And so we get x is equal to 8. Is that right? 8 grams of the 40% alloy. How do we find y? Okay, into either equation, right? In this case, let's say 8 plus y is equal to 20. So y is equal to 12 grams of the 60% alloy or gold alloy. Any questions about this? To eliminate the variable, most people do substitution. It's okay if you do x equal negative y plus 20 and plug in. Yeah, you can choose whichever method you want to use to solve the system. Oh, we chose that to eliminate the y variable because this is a 0.6. We wanted to create the opposite. Yeah. But yeah, we could multiply it by negative 0.4 to eliminate the x variable.